And because of the huge demand and huge production, we also accumulated waste. One of it is some organic waste that we also address here in our facility. And not necessarily because in ADNOC refining, we have to take care of our environment as well. So we have a facility called PIChE, which deals with hazardous waste, chemical waste, organic waste. So the first one way of addressing this waste is through incineration, reducing volume. And for the past more than 10 years now, it's operating and it's not emitting any pollutants at all. And with this, the growing numbers of inventory on NORM has accumulated throughout the years since oil in UAE has been discovered in 1965. And since then, it was being thought about UAE that we have to dispose it properly. And ADNOC address on that. Actually, our facility has not been started yet. I'm going to share you about my slides right now. Can you give me a share for that, Mr. President, please?
Yes, paki-share, Sir Bing, ng slides. Then I'll just approve.
Yeah. It's still disabled. Okay, here we are. So I'm going on my slideshow here. This is one of our struggles here with the online one. Can you see my presentation right now?
Yes, we can see.
I'm just going to, yeah. So, in behalf of those not working in oil and gas, I've been working for the past 17 years in this industry. And since of my experience in the oil industry, I was hired by ADNOC Refining on this new facility that they are started now. It's still under commissioning. And it is the treatment and disposal of NORM waste. So because of its characteristic that is extremely hazardous to humans as well as the environment, because of its long-term impact, so they decided to set up this plant. So there is only 2 facilities here in UAE that we consider like under regulation with FANR. It's also under the International Atomic Energy Agency. So all over the world, there is one regulatory body internationally that monitors the activities of any nuclear facilities in order to safeguard that they must be used in peaceful means. So I'm going to share you a video about how NORM was being generated, a very short video about how NORM was being generated in the oil and gas industries. Let's take a look at it.
During the course of a day, nearly everyone is exposed to low levels of radiation from both man-made and natural sources. Naturally occurring radioactive material, commonly called NORM, includes all radioactive elements found organically in the environment. While health risks from exposure to low levels of NORM are minimal, the extraction and production of oil, natural gas, or minerals can cause NORM to accumulate in hazardous concentrations, harming internal tissue and organs. There are 3 basic exposure pathways, or routes of exposure, by which NORM can affect the body. Radiation is the process by which energy is given off in the form of particles or electromagnetic waves. When unstable atoms decay, they emit radiation as a byproduct. Surface contamination exists when radioactive material is deposited onto a surface. When ionizing radiation damages cells in the body, the effects can be both short-term or long-term. The most serious long-term effect of radiation exposure is an increased chance of developing cancer. When the DNA of a cell is damaged by ionizing radiation, there are 4 possible outcomes. In relation to norm, exposure describes the amount of radiation that is traveling through the air. Dose describes the amount of radiation absorbed by an object or person. OSHA has set annual radiation dose limits for workers that are occupationally exposed to radiation. Radiation protection programs are required to inform employees when radiation hazards exist, provide sufficient safety training, and supply PPE and protective clothing. To measure radiation levels in the workplace, norm surveys must be conducted and documented by authorized personnel. When leaving a norm-contaminated area, a full-body scan, known as frisking, must be performed to check for contamination. The low levels of radiation that we are exposed to do not usually present hazards. While norm rarely poses an immediate danger, hazardous concentrations can accumulate in the body due to chronic exposure. By being aware of norm in the workplace, knowing the current radiation levels, and using control methods, occupational exposure can be kept as low as reasonably achievable.
Okay, I'm going to give you, can you hear me now? This audio is okay for everyone?
Yes,
I
it
cannot
is.
see. Yeah, just give me a feedback of the audio. So anyways, this is a short insight about our, our facility. Our contractor, I get all this information from our contractor. I don't want to show anything that is a propriety from a company. This is an open information coming from the internet. In Texas, as our what you call this, our contractor is setting up this project, which is a grassroots complex of handling, treatment, and disposal system of natural occurring radioactive materials, solid waste from the waste industrial area. It composed of hydrocyclone, incinerator and gas exhaust treatment with scrubber, concrete, which we're going to encapsulate it with concrete to immobilize and reduce the exposure of gamma radiation or ionizing radiation. The scaling pipe cleaner, we have 2 automatic, and there is also a manual descaler. Centrifugal pumps, water evaporation pan, landfill, which is with access road, and non-related process buildings. Actually, one of these uniqueness of this facility is we have 3-in-1. So first, we have all the different treatment that we have, like descaling and incineration, and also solidification. While at the back of our facility, we have our surface landfill, which eventually is good for 30 years. Abu Dhabi Refining Oil Company has common facility at Central Environment Protection Facility in Riyadh. Riyadh is an Arabic word, means environment. So we really take seriously in account of environmental impact in this country. So that is why we really have to protect that any kind of waste generated by the industry can never be a source of problem in the future on the next generation. So what is norm all about? So radiation is everywhere. We call it the background radiation. It is minerals that is traces of naturally occurring radionuclides. We call it natural radioactive materials. So we are continuously exposed to radiation, and 80% is coming from natural sources. They might be as radon gas, one of a very radioactive gas, which is liberated through the surface of land, and it might be trapped inside house. It's around 42%, mostly around the world, who has a very huge deposit of uranium. And also in food, we have food account for 9%, which is in form of potassium-40. So we ourselves, we are radioactive materials. So we possess norm in our body. And soil, as well as cosmic. When we go cosmic travel, we also receive radioactivity, radiation coming from space. And the rest, 20%, is artificial, which is coming from our medical facilities. So there is a pathway how norm is being created from its parent radioisotope, uranium, and the most stable one is uranium-238. Usually, natural radioactive materials only exist at the end of the heaviest element, which is uranium, and the rest is being fabricated artificially in the lab. So based on this decay chain, some of it are soluble minerals, some of it is gas. By the way, soluble one is a radium-226 or radium-228. And because of the presence after, we call this chain after uranium, they are called the daughter isotopes. So if you look at the chain, it is simultaneously produced, but in a different form with different half-lives. So some of them, as you see, like the parent isotopes, means billions and millions of years to decay, its half-life. And some of it is thousands or several hundred thousands of years. Some of it may be like months, days, and some of it minutes or seconds. So the only issue about radium-226 is it's a long life. Its half-life is 1600 years to decay. So based on this decay chain, we are only interested with the two decay chain that is serious about norm. It came from, another chain came from uranium-238, and the other chain came from thorium-232. Why we have to consider these two parent chains? Since it will produce, according to its natural environment, the decay chain produces a different kind of isotope as well. Although thorium-232 came from uranium-238, however, based on the decay chain in thorium series, only in thorium-232 that radium-228 is being produced, which is around 5.8 years of half-life. While uranium-238, it can produce radium-226, which account to 1,600 years to decay. So this is more potential harm than uranium-238. If it's being stored since 1985, when ADNOC refining started refining petroleum products, we accumulated a lot coming from the offshore companies. So with this, we may consider that radium-226 are now most likely very few in existence. While radium-226, I guess, for a lifetime, we still have to manage this. So why we have to bother about norm? Norm is typically a low ionizing radiation emitting material. However, because of the technological intervention of it, it concentrates and it is more radioactive because of the volume and becomes potentially hazardous. So the objective of our waste management is to treat and dispose norm as safely as we can. So why we have a legal requirement for this. So according to IAEA, or International Atomic Energy Agency, certain operation can give rise to significant enhanced exposure that we need to control by regulation. Meaning, no matter how small it is, it can be accumulated through our body through doses. So material giving rise to this enhanced exposure has become known as natural occurring radioactive material, or NORM. In several processes, activity concentration enhancement will be observed in generated waste or residues. So this is how IAEA classify the radioactive waste. It has two characteristics. One is the activity concentration, and the other one is half-life. So as radioactive material decay, according to their half-lives, they potentially go into a stability at a certain level where it can be below the background radiation. So since norm is slightly above background level, so it is still considered potentially harmful. Because of this long half-life, long-lived half-life, so it is considered that we have to dispose, immobilize it in order not to contaminate the environment as well as people around us. So this is where we concentrate our disposal level. It's landfill disposal. The rest will be something more complicated. So we have to set boundaries, how norm considered as norm. So activity level concentration is 1 becquerel per gram. That is the, we call it background activity. So anything above 1 becquerel per gram is considered potentially harmful, and below it could be safe. So we call it anything above 1 becquerel is a regulated material, and the rest will be considered as clean one. So according to our regulator here in UAE, which we call it FANR, or Federal Authority for Nuclear Regulation, one of the most looked document is Regulation 24. It stipulated all the basic safety standards for facilities and activities involving ionizing radiation in any kind of nuclear facilities. So since it states there that possession, manufacturing, handling, or storage or disposal of any of such must be under regulation. So aside from that, we are constantly monitored that activity concentration must not exceed its applicable limits. So one of its baseline is anything above activity of 1 becquerel per gram in terms of uranium and thorium chain of daughter isotopes. Anything above it will be considered as regulated material, as I've said previously. So why K40 or potassium 40 has 10 becquerel? Because we are more radioactive than our natural background. So mind you, we don't die even though we have such high activity, since it is inherent in food and everything else around us. So what considers is the additional radiation that we may absorb or ingest if ever we became contaminated with any norm. So norm in in oil and gas production. So we have two sources. The upstreams is the exploration, where we provide path for natural occurring radionuclides in terms of water formation. In the downstream, it can lead into concentrating norm, into forming into sludge in some tanks or any storage vessels. So norm may accumulate in wellheads in form of scale. It might be on the pipelines, it might be on valves in the Christmas tree, and in an oil gas separation, it will form as sludge. In gas plants, thin films as a result of radon gas decay. Since norm can be carried out in two ways. One is by leaching down radium-226 can be leached as in form of soluble in water, like its counterpart calcium, strontium, and barium, which is typically stable elements, except for one, that radium is a radioactive material. So it precipitates as a chemical reaction out of the leaching of water as radium sulfate or radium carbonate. So it builds up scales on the inside the pipeline, which reduce the capacity. So eventually, in the long years of operation in the offshore side, they constantly replace pipes, which has been the capacity of oil flow is being reduced. So because of the regulation, it's either that they can descale it, or we can basically, the only way is to descale it. And those decontaminated metallic part can be cleared, and we can recycle it as well, but not back to its purpose, but it can be smelted down to become a new material. So sludge can be accumulated in tank bottoms, gas oil separators, dehydration vessels, storage tanks, and waste bins. So other in between are called miscellaneous. And these are the valves with a very odd shape, which we do it manual descaling in our facilities. So from the two major source of material, radioactive waste as scales and sludge. So the third one can be miscellaneous equipment. They can be considered as burnables or non-burnables. So upon accepting it in our facility, we have to make sure that they can be characterized as dictated by the regulation. So any analysis of data provided by OPCO as per Waste Transfer Protocol, or WTP, must be verified by radioactive waste characterization. We use a special kind of equipment called high resolution gamma spectrometry to detect a very low ionizing gamma radiation. So samples are being analyzed in the facility by our laboratory, reading with handheld equipment to make sure that we will know the dose that is being emitted as it is inside a containment. An analysis of packages must be verified as well. It should be like stable. So characterization is one important tools to make sure that everything will be safe out of in our facility. So there are only two potential hazards here: an external exposure in terms of gamma radiation or ionizing radiation, which is in fact it's very low, but the most hazardous one is when you have physical contamination of norm. It can have three routes. Either you can inhale it through inhalation, or you can ingest it, or it can be absorbed by skin or any kind of open wounds. So radiation protection aims to keep radiation exposure as low as reasonably achievable. So this is the end of my short background on the norm. I'm going to show you now about the IEAA waste management of radioactive materials on the next video.
In Austria, technicians check the welding on pipes for a hydropower plant. Over in Indonesia, spices are being cleared of biological contaminants. In Budapest, pharmaceuticals are being created. And operators run a Chinese power plant that provides electricity to thousands of homes. These are common activities, taking place every day in many parts of the world. They rely on nuclear technologies that use radioactive materials. The benefits of these technologies, whether used in agriculture, industry, or medicine, are plentiful. Like other processes, they generate waste. This waste contains radioactive elements. People and the environment must be protected from the potential hazards of such waste, now and in the future. So countries need to manage their radioactive waste safely and securely, and make sure it's kept under control. This responsibility starts as soon as a country decides to use nuclear technologies. And techniques are available to manage radioactive waste. Radioactive elements are unstable and emit radiation as they decay. The decay rate is measured in half-lives. This means the time it takes for the activity of a radionuclide to halve. After another half-life period, the activity is again down by half. This continues, and eventually the material emits only negligible amounts of ionizing radiation. Each radionuclide has its own half-life. So waste can be hazardous for periods of time stretching from a few hours or days up to hundreds of thousands of years. Radioactive waste is classified depending on the half-lives and the level of radioactivity of the nuclides it contains. According to the IAEA's safety standards, there are 6 classes of radioactive waste. Each waste class has different management and disposal needs. Techniques exist to manage this radioactive waste and the spent nuclear fuel from power plants and research reactors in a safe and secure way. Waste containing only radionuclides with very short half-lives can be stored for a few days or years to allow for the decay of the nuclides. This type of waste is usually generated when radioactive materials are used for research or medical purposes. Eventually, it can be disposed of as conventional waste. Other waste forms need to be managed for radioactive waste disposal. By volume, most radioactive waste has low levels of radioactivity. This includes the majority of the waste that comes from the routine operation of a nuclear power plant, and waste that's produced when medical and industrial devices that use radioactive sources are no longer needed. This could be because the source has decayed and the remaining radioactivity isn't strong enough for its original purpose, or the device is damaged or obsolete. In these cases, the radioactive source needs to be removed from the equipment and prepared for storage and eventual disposal. Some countries process their waste at centralized waste management and storage facilities. Upon arrival, the waste is controlled to check for any surface contamination, and the radiation levels are measured. Details of the waste type are noted for the inventory before the waste can be processed further to prepare it for storage and disposal. Such processes can involve measures to reduce the volume of the waste, such as compaction and incineration. Encapsulation is used to immobilize the contaminants. After being placed in appropriate containers, the waste is stored. It will remain in this kind of facility until a suitable place or system for its disposal is established. Many countries already have near-surface disposal sites for waste with low levels of radioactivity. These facilities can consist of silos in the ground, trenches, or vaults. Once they're full, they will be backfilled with grout or soil, sealed and closed according to their disposal license. Alongside the radioactive waste produced by the routine activities at a nuclear power plant, nuclear power generation produces spent fuel or high-level waste. Such waste is low in volume, but has a high level of radioactivity, and it remains hazardous for thousands of years. In some countries, the spent nuclear fuel that can no longer be used to generate electricity is reprocessed to extract usable material for new fuel. Other countries consider the spent fuel as waste for direct disposal. In all countries generating nuclear power, the spent fuel is currently stored either in water pools or dry casks at secure storage facilities. Waste management experts around the world agree that underground geological disposal is the best and preferred option as a solution for high-level waste and spent nuclear fuel. This would be in a location where geological conditions are stable and the waste can be contained and isolated from humans and the environment until it no longer presents a hazard. While there's still no geological disposal facility of this type in operation, some countries have already selected a location, designed the facility, and conducted safety assessments. A few, for example, Sweden, Finland, and France, are well advanced in their development. Radioactive waste with low and intermediate levels of activity is already being disposed of in geological facilities in several countries. Since its inception, the IAEA has assisted its member states to safely manage their radioactive waste. The IAEA produces internationally respected safety standards and offers technical guidance. At its headquarters in Vienna, Austria, the IAEA hosts meetings and workshops, bringing together experts from around the world to exchange experiences. International teams, led by the IAEA, review security measures at waste storage facilities. The IAEA also helps countries to securely store high-activity sources in advance of disposal. Its experts run training courses in radioactive waste management and conduct missions worldwide to assist with the conditioning of disused, sealed radioactive sources. Its safeguards inspectors make sure that all nuclear material, including spent nuclear fuel, is accounted for and used solely for peaceful purposes. As populations grow and nations develop, we'll be making more use of nuclear technologies. This will result in more radioactive waste. And more waste means more needs to be done to meet the challenges. With the technologies now available, the new developments in the pipeline, and the continuous support of the IAEA, countries are well equipped to manage radioactive waste safely and securely.
Okay, on the next show, it's a movie clip, is a similar process where in UK, where our technology came from. So, except for one on the process is the incinerator. Let's take a look at it.
Descaling. Decontamination. Delivered like never before. Norm Solutions provides an all-in-one service for the management of naturally occurring radioactive materials, also known as NORM. We are able to handle and decontaminate a wide range of materials from oil and gas production, including tubulars, valves, filters, Christmas trees, umbilicals and risers, as well as handling contaminated sludges, sands, pig wax and PPE. Our facility in Aberdeen has substantial storage capacity and full RSA authorisation from the Scottish Environment Protection Agency, meaning we can handle NORM items and equipment from decommissioning, offshore activities and other large projects. NORM items arrive on site, are booked in and then are safely stored before processing begins. Our processes are dismantling, decontamination, tubular descaling, water treatment and scale disposal. Where required, equipment is transferred to the strip-down bay and dismantled into its component parts in preparation for decontamination. Individual parts are then descaled using ultra-high pressure jetting. tubulars have a standard shape, so are treated using an automated high-pressure jetting process that minimizes human exposure. Finally, the resulting norm material from each activity is filtered and treated. The filtered norm scale is collected and treated prior to being transferred to a suitably permitted disposal facility. Decontaminated water is recycled back into the system, and as all activity takes place in a fully enclosed environment, there are no discharges to the atmosphere or water systems. Norm Solutions is a joint venture between metal recycling and trading group John Laurie and hazardous waste management specialists Enviroco. Ask us about your descaling needs today.
Okay, except for one, I highlighted this incinerator because this is the heart of our waste treatment facility. However, incinerator is the ultimate solution for most of our waste management, especially in our country. So we have a big problem about domestic waste. So I'm going to highlight this incinerator, even though if we can incinerate highly or extremely hazardous material like norm. So why not use this as solutions for our domestic waste?
Our society produces a lot of waste, over 2 billion tons per year, in fact, a number that's expected to grow by 70% by 2050.
That's a line of garbage trucks stretching from San Francisco to New York City every single day.
Organic materials in landfills decompose, they produce methane, a very potent greenhouse gas.
Solid waste, plastics, paper, cardboard, there's a lot of energy within those, carbon and hydrogen.
Why don't you do something useful with it?
Converting waste into energy is not a new idea. Usually, though, this has meant incineration, that is, burning our trash to recover some energy. But that has major drawbacks. Incineration creates toxic ash and hazardous chemicals called dioxins, and heat and electricity are pretty much the only usable outputs. A better solution may lie in gasification, an old technology which has only recently been repurposed as a way to deal with our waste. Gasification companies don't burn trash. Instead, they turn it into a gas, in a process that they say is both economical and eco-friendly.
The focus is on producing a good quality syngas that can be converted into higher value energy products on the back end, be it electricity, hydrogen, diesel fuel, possibly even chemicals, fertilizer, etc. in the future.
It's an exciting idea, and some major players, including the Bill Gates-led fund Breakthrough Energy Ventures, have thrown their weight behind it. While in the past, gasification companies have struggled to scale up and meet their energy production targets, now companies like Sierra Energy, Enerchem, and Plasco say they're ready to commercialize and expand.
I think we have over 9,000 interested parties from around the world who've contacted us already. The question is, how quickly can we get one? The answer is soon.
The world's first municipal waste incinerator was built in 1874 in Nottingham, England. And like incinerators of today, it converted trash into ash, gas, and heat via combustion. Initially, the purpose was just to shrink our waste. Eventually, though, Great Britain and Germany did start recovering energy from the process, but the idea didn't really catch on in the US. Domestic electricity prices were already low, and as emission standards tightened, incineration got even more expensive as compared to landfilling. It wasn't until the oil embargo and resulting energy crisis in the 1970s that the US really took an interest in waste-to-energy tech. Over 100 waste-to-energy incineration plants were built, but when fuel prices dropped, interest waned.
You see a lot of interest on this waste conversion or biomass conversion when the fuel price is really expensive. And then when the fuel price drops, nobody really cares.
Today, there are about 70 waste-to-energy plants in the US, and the number is declining. But globally, many European countries still rely heavily on incineration, and Japan and China have been building waste-to-energy incinerators at a rapid clip. But many environmentalists say we need a better solution. Incinerators still emit harmful pollutants, especially in countries with lax environmental regulations.
So burning waste to get rid of it may appear to be cheap, but the long-term health consequences for the community is terrible.
So companies like Hart Sierra Energy are looking towards gasification, an old technology that proponents hope to repurpose as a cleaner and more economical waste-to-energy solution. In the gasification process, materials aren't combusted. No toxic ash or dioxins are produced. Instead, a highly controlled amount of oxygen or steam reacts with the waste, turning it into a gaseous mixture of carbon monoxide, hydrogen, and other elements. This synthetic gas has applications beyond electricity generation. It can be converted into high-value products like diesel fuel, hydrogen fuel, or ethanol. So even if electricity prices stay low, there'll be a market for these outputs.
We see much more value in chemicals and biofuels. Methanol is an important building block in the chemical industry. Ethanol is, of course, as you know, can be blended in fuels.
In this way, waste-to-energy gasification plants have both upstream and downstream revenue potential.
On one side, you're being paid to take garbage that normally would be dumped into a landfill. So that's one source of revenue. You then take that waste and you turn it into recycled products. Those products have very high value. And so from a business model perspective, you're getting paid on both ends.
But a main challenge facing companies like Sierra Energy, Enarchem, and Plasco is dealing with the unpredictability of using municipal solid waste as the fuel. Globally, there are hundreds of gasification plants that generate electricity from fossil fuels like coal, but waste-to-energy gasification is a whole different game.
Tailoring your gasification when your fuel changes over time is the holy grail. And if they can consistently gasify and produce their natural gas from these waste materials, even if the content changes, that's an exciting option.
Here are some of the main players taking that plunge. Davis, California-based Sierra Energy was founded in 2004. Back then, CEO Mike Hart, who is also the CEO of Sierra Railroad Company, was seeking to improve the fuel efficiency of his locomotive fleet.
We were trying to figure out a way to make our own fuel. We wanted to do something better than diesel.
He was judging a business competition at UC Davis when he heard about how blast furnaces, one of mankind's oldest technologies, could be used to convert any mixture of materials into a usable synthetic gas. Hart bought the patents to this technology, and Sierra Energy was born. Over time, its mission expanded far beyond its initial reach.
People are realizing that climate change is a very real problem. When you throw away 1 ton of garbage, every ton is about 6.2 tons of CO2 equivalent goes into the atmosphere in the form of methane. Methane is 86 times more potent a climate change gas than CO2 over a 20-year period. Our technology provides one way of trying to address that problem.
Last July, Sierra Energy closed its $33 million Series A funding round, led by Breakthrough Energy Ventures, the Bill Gates-led investor fund that also includes Mark Benioff, Jeff Bezos, and Richard Branson. Now, the company has partnered with the Department of Defense to develop its first small-scale commercial facility at Fort Hunter Liggett in Monterey County, California. This demo facility can handle 20 tons of waste per day, and if all goes according to plan, it will begin processing trash in early 2020. Ultimately, Sierra Energy says what sets them apart is their use of the blast furnace, a centuries-old technology in the iron and steel industry. Here's how it works.
A blast furnace, which is the technology platform that Sierra Energy uses, is a high-temperature vessel. Solid materials go in at the top, injectant gases are placed in at the bottom, and you have a big countercurrent heat exchanger. We're injecting oxygen and steam at the base instead of hot air. And at the top, we're placing in solid waste materials instead of those mined materials from the ground. And instead of the focus being producing good quality metal out the bottom, our focus is on making a good quality syngas, synthesis gas, out the top of the vessel.
Once the syngas is produced, the local community or developer will decide what to do with it. The company lists electricity, hydrogen, renewable diesel fuel, and ammonia as likely end products. About 10% of the waste material can't be converted to gas, and so is instead turned into a stone that can be used as construction material. Because of this wide variety of use cases, it's hard to say for sure exactly how clean the end-to-end process will be.
It really depends on the specifics of the project, how far waste is having to be brought to the location, some of the configuration of the plant itself.
Hart is confident, though, that in almost every case, it will be carbon negative.
Because even if you're making electricity or diesel for a vehicle, the amount of pollution that comes out of the tailpipe or smokestack is less than the amount of emissions that you're offsetting in the first place.
Furthermore, Sierra Energy's plant doesn't rely on external energy to operate. Instead, Hart says that about 20% of the energy created is used to run the plant itself.
And so by some people's analysis, you can make this carbon negative or carbon neutral. By other analysis, you can't quite get there, but it's certainly cleaner than fossil natural gas.
Over the next few years, Hart says the company plans to build out community-scale systems that can handle about 50 tons of waste per day, the equivalent of approximately 50,000 people's trash.
If we want to have an impact on that 13.2 billion tons a year of greenhouse gas, we need to have thousands of these systems around the world as quickly as possible. That's our goal as a company.
While Sierra Energy's most recent funding round has put it in the spotlight, there are a number of other veterans in this space. Two of the biggest are Plasco Conversion Technologies, founded in 2005, and Enerchem, founded in 2000. Like Sierra Energy, both aim to turn municipal solid waste into valuable end products through gasification. But unlike Sierra Energy, these two companies have actually accumulated years of firsthand experience operating full-scale gasification plants, dealing with their fair share of delays and setbacks along the way. Plasco Conversion Technologies uses plasma to refine the waste from gasification into a clean syngas. The company operated a large demonstration facility in Ottawa from January 2008 to January 2015, capable of accepting 135 tons of waste per day. Eventually, Plasco got approval to build a commercial-scale plant, and though the company raised over $300 million, it ultimately wasn't enough. The new plant was never built, the demo facility shut down, and Ottawa severed ties with the company. But Plasco kept chugging along and re-emerged with a new outlook on the market.
We put in 1.2 million man-hours and a decade of work and $407 million. We can tell you many ways it don't work, and what we do now does work. In the process, we realized that the waste to electricity market, the waste to energy market, was going away.
Unable to compete with the low price of natural gas, Plasco now aims to produce synthetic fuels for use in internal combustion engines, which can power cars, planes, and trains. The company no longer operates any plants, but it says there are a number of projects in the works. And for these future endeavors, Plasco has slimmed down its business model.
We aren't doing build, own, operate, transfer anymore. We're doing selling the equipment and the technology. So we restricted what we did so we weren't in competition with the entire world, but more in cooperation.
Another player, Enerchem, developed the world's first commercial waste-to-biofuels facility of its kind. It's been operating in Edmonton, Canada since 2014, and is currently focusing on turning trash into ethanol biofuel and chemicals like methanol.
It's a facility that can take up to 100,000 tons per year of waste, around 300 tons per day. So this type of size would represent a community of around 500,000 to 700,000 inhabitants.
This plant uses a technology called a fluidized bed gasifier, in which the trash is dropped into a bed of hot sand, oxygen, and steam. The precise mixture causes the waste to heat up and turn immediately into gas. But Enerchem has also faced challenges as it scaled up. The company initially predicted its first plant would operate at full capacity by 2012, but it still isn't there yet. The company won't reveal how close it is to full-scale operation, but Chornay says that despite the delays, he's glad that his company is taking the time to get it right.
We're really proud that we did not skip any steps. However, this comes at a cost. So we have both a patient approach and a realistic approach for innovations of this scale, and also we have an enormous database as well as operation time at commercial level. So these three aspects really differentiate us.
In its 20-year history, Enerchem has raised $616.5 million and now has plans to build additional facilities in the Netherlands, Spain, the UK, and Canada. It's one of the most well-established companies in the space, but with just one commercial facility, there's still plenty of room for others to play catch-up and learn from what's worked and what hasn't.
Everyone likes to be in the race to be number 2. The idea is the first plant, the pilot plant's more expensive, so you'd rather learn from somebody else. On this topic, I'm not at all worried. The first one at large scale may have some kinks in it, but it's also likely to get some of the best subsidies and deals from the municipality.
These potential subsidies, alongside other policy drivers, stand to play a major role in determining how quickly this tech spreads.
So the future for gasifiers is, in my view, more tied to the economics of the climate change story, the prices on carbon, the prohibitions on emitting any fossil fuels, than it is on the technology, which we've known about for a long time.
Given current policies, such as California's low carbon fuel standard, Sierra Energy says it could build many more plants, but not on the scale that they'd like to see eventually.
To get to hundreds is very feasible, but to get many thousands, that will need different regions of the world to step up and force people to divert waste from the landfill.
This could look like higher landfilling fees, carbon credits, carbon taxes, emissions regulations, or subsidies. Any and all would be a boon, so long as these gasification companies can operate as cleanly as they claim. But as climate policies and priorities shift in tandem with election cycles, it can be hard for this tech to establish a strong foothold.
Once we know, okay, this is the policy that we're going to stick with for 10 years, I think there will be a lot of confidence for these investors. But if you don't know what the policy is going to be in every 2 years or 3 years or 4 years, it's very difficult to make any decision.
But as our landfills fill up and the world gets hotter, companies, investors, and the public at large are realizing that we can't wait much longer to seek novel solutions.
People who say, we'll recycle our way out of it using conventional means. Those people are out of their minds. It's not happening. If we're going to do anything to try to reduce climate change, those 13.2 billion tons of CO2 equivalent going into the atmosphere from landfills is the very first place that we should try to address it.
Okay, thank you guys for your patience. I have here a link that will lead you to some kind of online quiz about radiation safety. I'm going to share this with you in a while, and after you can do this after the webinar, and you can have a certificate after answering this. It looks like this. So I hope you enjoyed the presentation, and you can submit this certificate to our president, just an evidence that you have attended this webinar. Thank you so much, and have a nice evening or good afternoon to all of you.
Yes,
This
thank
is
you.
the link now. I just
Yes.
sent it. Then you can
Yep.
do your online
Thank you, sir.
test right after.
Okay. Thank you, Sir Bing.
I can't hear anybody here.
I'll hand over the floor back to Becky. Becky?
Okay, thank you very much, Sir Bing, for that very informative presentation. So now I've learned about norm. Not only I got it from my college years.
Right now.
So now it's the this one, the realization from the theory of chemistry. So now we will cater for the questions from our participants. So what we have here, we will first.
I can't hear. My audio is going bad. I can just.
Sir Bing, can you hear us? Can you hear me?
And then re-enter again. Is it okay? I can't hear anybody here.
Sir Bing, can you hear me?
I have to leave and go back again. Can I do that, Mr. President?
Yes, I've sent a message. I think you can't hear me. All right. Sorry, guys. Let's wait a few minutes. Let's wait for Bing to sign out and sign in again.
Anyway, so how's everyone? How's everyone from UAE and from Philippines?
All good?
Good. All are good. Okay.
Yes.
So,
So if you have questions, I guess you can throw it sa chat window natin.
Really, it's really bad. I'm
We
going
have
to
a
leave
few
now and then
questions.
I'll just go back later, okay?
Yes. So I think there's a few questions now sa chat window natin, and Becky will go over these questions. So kung meron pa, just throw it in there and we'll answer it later. And by the way, we'll also try to provide you the resources, yung slides, tsaka yung links to the videos, so you can refer to it after the seminar. And I think dun sa mga naka-attend din ng webinar last time, we'll also try to release those presentations. Okay, so I think si Bing ay logging in na. Hello, Sir Bing. Do you hear us? I hope you can. Nakamute ka, Sir Bing. Can you unmute, please?
Sorry.
Okay,
I'm,
all right.
okay.
I was so scared. This same thing that I encountered last night. I cannot hear
Okay.
you.
No worries.
Okay.
All right.
Okay, sir. So, shall we start now, sir, with the first question?
Sure, no worries.
Okay, so the question is coming from Engineer Romeo Apolega. Is the norm considered for medical purposes?
No, it's not. It's a waste. We cannot recycle it at all. Its only way is to dispose it safely through reducing its volume, immobilize it by mixing concrete and dump it in the website. It takes years. It's a very low emitting gamma, so it's no use of anything.
Any follow-up questions for Sir Romeo? Nothing? Okay. Okay, so I will move to another question.
Yeah, sure.
Okay. Can norm occur in gas refineries and natural gas processing?
Yes, it is. In fact, that is one of the oil and gas waste that we have to address for, because it just accumulated over time. The reason why it was not being considered last time, because there was no such facility here in UAE or anywhere in the GCC.
Okay. So is there a follow-up question, sir? For Sir Romeo for that?
I think my last question was, there was no mention of scrubber for the tower. No scrubber for the fumes. There was no mention on that. On the treatment of the air, of the fumes. There was no mention of scrubber.
Okay, the video that I was showing is not of a norm-specific one. It's a general concept of converting domestic waste into as one of a special kind of incineration. In our case, I didn't show you because I cannot find one video in a sort of. So I'm going to explain that in norm treatment facilities, we have the incinerator that has a scrubber. Everything has been dealt with as in zero emission to the environment. We have a lot of filter bags, neutralizing, and all the NOx and all these hazardous toxic chemicals that can be associated with the effluent is stripped down inside. I cannot show you actually because I cannot find any video about it, but it has a scrubber. And we also monitor our stock. Like our BIAC, which is operating now for more than 10 years, the only effluent that we have in our stock in the incinerator is purely carbon dioxide and water vapor.
Currently, I'm into the solid waste to energy to steam laundry. It's happening now.
Yeah.
I'm now into it. Solid waste into incinerator, then big boiler, then produces steam, and a big steam laundry is now getting the steam from the waste, from the solid waste. That's why I questioned, there was no mention on the scrubber, which we are doing now anyway. The ASH is being produced, is being collected for two purposes: compost and hollow blocks or bricks.
Yeah.
Yeah.
Okay. Based on the video that I'm showing, that is a different concept of incinerator. It's a special one, and it's still quite new. If you can see about the date, it was barely a year ago when and when they released it in YouTube. It was like 2 months ago, and that is fairly new. The technology is fairly new. However, in our case, that's why I don't focus so much about norm, because norm is basically a nuisance on oil and gas as a waste. So there is no use at all, because first, it has a very low calorific value on it, mostly composed of non-burnable materials like scales and a very small amount of oil in terms of sludge. So we use an external heating fuel or gas just to make sure that we can burn it all of it and turn into us. That's the only reason. That's why we cannot have a cogen about norm. Secondly, in our BIAT, since fuel here is so cheap, so turning it into electricity is not so viable here in UAE.
Okay.
Well, last question. Last question.
Go ahead.
There was, on the solid waste energy, there was no mention of dioxin.
As I said, that technology using either conversion is gasification. It's called gasification. Actually, you are basically subliming all these materials, combustible matter, into more useful gas. And through chemical process, we can convert it directly into useful products like ethanol, diesel, or hydrogen. However, on the other technology that is being shown on the video, it's called a plasma. The plasma is totally destroying everything that goes into hand, making it into a molecular level or ionic level, and turning more efficient in turning into fuel.
Thank you. Thank you.
Okay, thank you very much, Sir Romeo. So another question here from Engineer Florencio. Will be a cater for the waste disposal of the new nuclear power plant in UAE?
No, it is not. Our license is only a deal for normally natural radioactive materials. Anything that going in as artificial one, it cannot be disposed there. Our license is based on our operating license. We can only receive norm. That's why there is a characterization upon recipient on any kind of waste. And beforehand, they have to present a document that it stated the fingerprints of the waste that they're going to send in our facility.
Just a follow-up question, Becky.
Yes, sir. Okay, sir. Go ahead, sir.
Regardless, let's just disregard the license that your facility has. Does that mean, is your technology, your current technology, able to treat these artificially produced nuclear waste or waste from the nuclear power plants?
No, it is not designed for any norm. In fact, we cannot handle highly ionizing radiation except for those contaminated by PPEs that we are thinking about. But in the source of origin, like artificial origin, once we can find any artificial isotopes, we automatically reject the shipment, whatever reason.
Okay, thanks.
Any additional questions, sir? Sir
I'm fine.
Albert? Okay, okay. Okay, another question here. Have there been instances where norm waste were discharged or disposed to the sea?
Yes, there is. Basically, before the disposal is being created here is being established here. In fact, it's not established yet. We are still on our commissioning stage. The Aramco, one of Aramco representatives visited our facility, and they used to re-inject scales and sludge back to the wells, which they found it very like conservative, because they might think that they're going to contaminate oil as well, but in fact it's not. But for purposes of like confidence of investors, they have to dispose it clearly as safely as it can.
Okay.
Mm.
Okay, thank you, sir. So another question, any
Yeah.
follow-up questions, sir? Okay,
Yeah.
go
Sorry.
ahead, sir.
Prior to, I mean, with that practice, were there observed impacts to the sea or anywhere due to that disposal practice?
No, because usually they re-inject it in dead wells, which in fact, basically it's just like a sort of two things. Re-injecting back waste is just like building up pressure on these wells, because as you explore wells, pressure depleted and extracting the oil becomes more inefficient. So, as I've said, the geographical formation of oil is not something like an empty space behind it. It is composed of porous rocks, so fine enough, like a sponge, that oil and gas has been soaked around. As you withdraw oil and gas through its own pressure, pushing it upwards, the differential pressure creating water to seep in. And that's how the wells is operating, especially offshores.
Okay, thank you, sir.
Okay, sir. So another question, sir, being, does incineration reduce radiation levels of norm waste?
It's constantly monitored all throughout the process, from the very start when we receive it, upon reception, until it end up to the landfill. We call this one as characterization, as I've been discussed on my presentation. This is a very important factor because according to regulation, everything should be accounted for, the inventory from cradle to grave.
Okay. So any additional or follow-up questions on that? I think nothing. So shall I move to other question from Engineer Florencio Jr.? How do we dispose the incinerator filters which might contain the radioactive isotopes or other applicable products of the combustion?
Any kind of facility like ours, we are also generating our own internal waste. So this internal waste, we have also considering burnables, and we put it in burnable boxes, and we incinerate it as well. So anything that goes in cannot get out until they are being disposed properly. And one way is to reduce its volume, and as it's being produced, mix with concrete and characterize it, and we have to make sure that it's been identified correctly, and we have a system called waste inventory record keeping system that tracks everything about it. And FANAR is monitoring all those inventories as well.
Okay, sir. So a follow-up question here. How do we dispose the ashes that might contain high concentration of toxins from incineration?
As I've said, that is one of the specialty of incinerator. Incinerator ashes, after that, it doesn't end that way. So we have a second stage called solidification. Solidification process is we mix the active ash. We call it active because it's containing a high concentration of radioactive materials. And we dilute it with clean cement. Clean cement means non-radioactive one. And we have a formulation for that. After it's being mixed, we put into drums, and the drums is going to be cured, and make sure that there will be no cracks. It can withhold pressure a long time because it can be stored forever in the landfill. So with that respect, all that aspect of disposal is being taken care of about the engineering controls of the facilities.
All right. Okay.
Yeah, follow-up question lang po. Sir Bing, I know that you have measures to abate particulate emissions to us, to comply with allowable limits. But have there been any studies or measurements conducted in order to measure radiation levels of, let's say, particulates that are released into the environment through the exhaust gases? I'm not sure how high is the level or low, but just curious.
The only allowable measure is zero. We have a zero emission. In fact, we have a monitoring at the stock, and everything that is going through the process, I've said, every step, there is a radiological equipment that is constantly monitoring as long as the process is going on.
Okay.
So with the release as like uncontrolled or unconditional shutdowns or something, once breaking containment, we have a wall-mounted radiological equipment to measure suspended particulates. I mean suspended radioactive particulates.
Yes.
Yeah. So anything that it will be alarmed, so we have to shut off. And by the way, all this, our facility has a very special kind of building. We call it negative pressure. We call it the I just call it integrated building. All the pressure is coming from low area going to high risk, and everything that we dispose back to the environment will be filtered out by HEPA filters, a series of filters. And the exhaust has another monitoring that it should be zero as well. You cannot see anything. Once that happens, all the plant will shut down.
All right. Okay.
Okay,
So
thank you, sir.
Okay, sir. So another question, sir. Were there incidents anywhere in the world where high levels of radiation were detected due to improper disposal of norm?
I don't think so. Based on the regulatory, it's the only allowable one is zero. When you are working, we have a very strict, it's a highly restricted operations. When we go there, there is an access control. It's just like going to an airport. Going into it, there's a series of like what we call it, dressing, undressing, that anything that goes in should be remain on the clear one. And then everything that is assumed, if you go inside the process area or the facility, it is assumed to be contaminated. So you have to undress and dress up accordingly. And there is an imaginary boundary, and we call it access control. And every worker that works inside the hot area or radioactive area, they will be scanned with contamination scanners, full body scanners. And there are 2 of them. So that is how tough. According to regulation, it's illegal to bring contamination out. So it's strictly controlled.
All right. Okay. All right. So any follow-up questions, Sir Helbert?
I'm good. Thank you.
Okay. Okay. So let's proceed for other question from Engineer Roy Importado. What is the capacity of your facility to handle the norm waste compared to the norm waste generation of UAE?
Oh, that's a very good question. In fact, the capacity right now, according to, we haven't started yet, as I've said, because there's a lot of formalities that we have to do. Even though we already have a license from FANAR, the only bad thing is that based on ADNOC OPCOs, even for 15 years, we cannot even reduce the current inventory into half. All about OPCOs, around 4 or 5 of them. So that is how big is the accumulation since oil has started exploration in UAE.
How are these wastes currently stored, Sir Bing?
Oh, it's not in our hand. We don't have a license. Storing is another So this is, what you call this? The license is very specific about the activity. So right now, one of the problem about the OPCOs is they don't have onshore storage about it. And that's one of the challenges they're facing right now. So our license storing is not, we are only allowed to temporarily store for processing it just like for a week. And we cannot have a lot of storage.
So do you have any idea how it is being stored now? No idea how it is kept?
People, when we have meetings with them, they have really trouble about it because since in offshore, it's a very crampy and crowded place. And during the some of the consultants, contractors that went offshore, their complaint is that everywhere else you can find any kind of reading of radioactivity. And it's very hard which one is clean, which one is not. So once they have to ship it onshore to make sure that they decongest all these waste coming, especially like tubular suites, they constantly have some kind of maintenance to maintain the capacity of the oil delivery to the shore.
Okay. Thank you, sir.
Thank you, Sir Dean. So another question here from Engineer Benedict Madariaga. How do you classify the radioactive waste in your company?
So NORM is classified as a low-level radiation and long-lived. That's why disposal is just simply on the landfill area, but it's strictly regulated, and we have boundaries with it. It's just like the security is very tough. Any kind of nuclear activity, they are really tough. Even going in and out of our facilities is just like going to prison. There are barbed wires everywhere.
Okay. Okay, thank you, sir. So we have last question here from our chat tool from Engineer Chris Dominic. Do companies having NORM require to have an in-house radiation officer or radiation protection officer? In Philippines, there is a license for this position. Yeah.
Right now, FANAR is imposing that for reason of regulation. However, they don't have established it yet, most likely. Even Saudi Aramco, when one of the representatives started there, they have a very hard establishing an RPO, radiation protection officer position in their company. And I do not know exactly about in the offshore because in this operation, there is two streamlines. The sources that we're going to send us the radioactive materials or regulated materials, and us, the facility that process and dispose it in our site.
Okay. So what about your radiation officer, sir? Do you have a certified officer for that one? Or
yeah, I am one of those. I am one of those. Regulation differ from country to country. While I was in Canada, I was working with a medical medical isotopes for cancer and also for imaging for diagnostics purposes. And in Canadian laws, the regulator there doesn't really need a license at all. All they have to do is train you and be competent about the job that we're going to do as a nuclear energy worker. And here it's different, but FANAR is still very, very young at that point, maybe like more than 10 years now. So they are still establishing all these regulated one. In fact, they are looking for qualified experts that will represent them in case some kind of consultancy is being asked from them.
okay. Okay, thank you, sir. So we have another question here from Engineer Florencio. Is there any NORM disposal facility in the world that uses supercritical water oxidation or plasma arc pyrolysis as alternative for incineration?
I don't think so. I have no idea about that. But as I've said, NORM is not something that you have to going to recycle it. But the only way is just reducing the volume and nothing else because of its long-lived material that stays on thousands of years. It's not practical to recycling it, not unless it's really going into something else.
All right.
All right.
Okay.
Becky, I have one more question, but let me give the floor first to Roy. I think Roy has something to ask.
Okay, sir. Please go ahead.
Sorry. I think being last time we were able to speak before, and I was one of those people who have raised the matter about radiation safety. I don't know whether you still remember me.
Yeah,
I'm the
yeah.
one working in the oil and gas industry that time and have idea about radiation safety as well.
Yeah.
Now, I just wanted to know because what is the how do ADNOC is managing their own radioactive waste, considering that your facility is still not yet operational, and secondary to the question that I later raised was considering that you have accepted that even for the next 15 years you could not be able to reduce even half of the existing radioactive waste of UAE. What do you think are the necessary measures that need to be considered in line with what you have right now in order to address the emerging problem, considering that okay, probably for the next 50 years, more waste will be coming.
On that aspect, we don't have direct link between the offshore people, but when we do meetings with that in that aspect, because they are our clients, they have consultants as a qualified expert about that. The only problem is the interim storage facility that might be closer to our facility, and that is part of them. And we don't get involved with that because, as I've said, we are only doing our part as treatment and disposal. That's the end point of it. And the rest is on the part of even transporting it, you need a license to have a transportation of any kind of work. It's not easy dealing with radioactive material since it's highly regulated.
Just to add on to this anyway, this is not a question, but to share my experience because I am handling Halliburton, Weatherford, Baker Hughes, and Schlumberger radioactive materials. And whenever there is a contamination of their tubulars and their drills with the norm, normally it is currently being sent outside of the UAE, most of the time in the US or in the Canada. So PANAR is still considering it as a regulated material, even though this is a minute quantity in with regards to norm. So is there any facility on your side being a coordinator, considering that you have a facility of waste management related to radioactive, that instead of directly going to the probably sending institutions outside of UAE to be coordinating with those counterparts outside of UAE, and you will be the middleman in between?
No, the only solution, the long-term solution about the UAE government is that this facility should facilitate whatever waste that we have right now. But due to the fact that we're not operating yet, that's the biggest challenge that the offshore is facing now. It's not, we still have so many issues about our facilities that it's a very big, it's a big job doing all this waste treatment plant. So we still have to deal with their own problems because it is out of our scope that we have to coordinate with them. As of now, they have their own problems to solve and we have ours too.
Okay, thank you very much.
Okay.
Excuse me, can I have one comment? I'm Florencio. I'm working in ADNOC, Bruges, in the process engineering group. And yes, since the BIAT before was not yet operational, we have some contractors also which are taking our waste. Also, especially for those which are radioactive and toxic. So now everything will be centralized with BIAT.
Yeah, that's correct. We are under Roy's Area Services Division, and we have 3 departments, which is GUP, BIAT, and the new department, which is NORM. They just set up this norm separately because they are being regulated. So it's only the waste treatment facilities divided into 2 parts, the regulated and non-regulated, which BIAT is taking care of for some time already.
Mhm.
Can I add one more, sir?
Yeah, go ahead.
Okay, sir. Go ahead, sir.
Yeah, because just recently Dubai municipality held a meeting among their inspectors, and they have discussed about norm, but not necessarily in the oil and gas industry, but more on the construction. Because as what you have discussed in your meeting, in your discussion, in your webinar, that 42%, if I'm not mistaken, of the radon coming from the underground, which is the source of norm, is being taken care of. Now, the thing is, after considering this as by Dubai government as one of the source of norm, apart from the oil and gas industry, how do you think that what's the vision of UAE, considering that at this point, your facility, although it's not yet operational, is the only facility that can take care of the norm waste once this, because construction industry, as you are aware, that is the bread and butter apart from oil and gas in this country. And upon knowing that 42% of the radon 226 or radon 228 is being generated whenever you are digging up during the construction industry, and what do you think is the UAE government's vision with regards to developing more of your similar facility also here in Dubai?
Actually, the inception of a norm facility here is basically for the accumulated all throughout the years of oil and gas waste. With respect to that construction industry, it's just found out because basically on previous years, nobody take care about norm because nobody has even take notice because it's just like it's everywhere. But now because of high concern of environmental issues, so they consider this to proper disposal of this stuff. Construction wise, yes, everything, everywhere in the world, there is always like they are all radioactive. Even sitting here inside the room with the concrete, cement, and any material that you're living with is radiating some non-ionizing radiation. However, this radon, as long as it cannot be trapped inside a container or it can be inhaled by anybody, the minimum amount of radon that is being released by those norm materials coming from construction is very negligible enough that will pose harm to anybody. However, as I've said, granite in our kitchen tables is very active while than anything else, and you can even sit on it, you can lie on it, there is no really potential harm. The only reason why oil and gas industries has to take care of norm because they are in form of particulate. When they dry up, while I was working with in Sharjah in BP, British Petroleum, it's a gas producing facility. We have a problem on our evaporating pans, old evaporating pans, and we found out that it is the pan bed is laden with norm sludge, and we cannot do anything about it. So what we did is just keep it wet all the time. The only reason why norm has been created because those that is being extracted mechanically, just like cleaning the vessels or separators, sludge is always within. And when they try to check it, survey, it contains norm. And the only reason is that once sludge dried up and it will form into very fine particulate, it can be driven by air, and it's very dangerous because inhalation is norm is far dangerous than the ionizing radiation of gamma that it imposes.
So, okay, thank you, Sir Bing. I have another question, additional question here. Please advise if there are special PPEs needed in handling scale samples. We are conducting scale analysis, mostly extracted from wellheads. So, any PPEs, Sir Bing?
Norm is just like any kind of ordinary chemicals, that hazardous chemicals, that the same PPE as long as non-permeable, like these disposable coveralls, and using it's wise to use like respirators we can advise that full face respirators with like positive displacement. There is some respirators of sort that is motor driven. There's a pump on the back of it with HEPA filters in it. So you can continuously working without any harm as long as you're in an open environment.
Okay, so that's it. So that would be our last question, Sir Bing. Any questions that you have still in your minds, you can contact Sir Bing. So Sir Bing, you can share your email address or any contact numbers where they can contact you or they can talk to you regarding on this subject. Okay.
Okay. I'm going to type in my personal email address. I cannot just give you my ADNOC because it's not.
Yeah. Okay.
Yeah,
Yes, sir.
I'm not doing this for consultancy because I'm working with ADNOC right now. So it's just like a matter of enhancing our profession.
Oh yeah. Yes, sir. We understand, sir.
So this is my email address, personal email address. I can address all your questions. It's not on behalf of ADNOC, but it's just like if you want to know more about the technical aspect of it, I can share mine, but it's not as consultancy because that is a conflict of ADNOC's interest. And my personal phone number, you can call me.
Okay.
So you can just call me anytime. I'm just working from home right now. So it's just fine. And just bear with me if sometimes I've been so talkative about this.
Okay.
If it's really good for you to ask questions, then I will answer. If not, I will find some answers for you.
Okay. So thank you very much, Sir Bing. We have new learnings for this webinar, and we're hopeful to have another one. Hopefully, we can schedule another one. So before we will end up this webinar, we will ask Engineer Eileen Cruz, our PIChE UA Executive Vice President, for the closing remark or closing statement.
Yeah, I guess just to cut off, Ms. Becky,
yes,
we have a question from Sir Floor about taking long flights exposure to natural occurring radiation. The thing Granite has mentioned as yeah, there are places with higher level. Yeah, that is true because the only thing about norm as radiation is based on three things. We cannot escape from radioactivity, especially radiation. So there are two types of radiation that we have. It's ionizing and non-ionizing. Even our cell phones is emitting a non-ionizing radiation. If you say that going in flight, long flight, like 12 hours or 9-hour flight, we are receiving more than what we get in our X-rays or anything else. However, they are not really imposing too much harm because for sure, it is being scattered. The focal point between the source and you is not that much. So it's not a really big deal for that.
Okay. Okay, thank you, Sir Bing. So can we have now any word from Engineer Eileen Cruz?
Okay. Hi, Becky.
How are you?
Okay.
Okay.
Hello, fellow chemical engineers, and to our dear guest.
Hello. Good afternoon.
So, on behalf of all the officers and members of the PIChE UAE chapter, we would like to thank everyone, all those 70 plus participants. No, tama ba? Nasa 70 plus tayo.
Yes, 70 plus earlier, yes.
Oh, earlier. For attending our second webinar. So, gusto ko lang din pasalamatan. Number one is our guest speaker, Engineer Ong. Thank you, sir, for sharing your knowledge. Thank you for sharing your knowledge and time dito sa ating successful second webinar. And then second, to all our participants dito sa UAE and especially yung mga taga Pilipinas. No, for sharing your time sa aming lahat, kahit gabi na dyan at magdi-dinner na kayo. And then third, to all those officers who share their time and talent to make this webinar possible. Pasensya na maingay yung background ko. And lastly, if you have other questions, please send email to PIChE UAE chapter. Pwede rin naming i-receive yung mga emails niyo and then we can send it later on kay Sir Ong. Okay, so thank you very much sa inyong lahat and see you next time sa susunod pang mga webinar and ingat po tayong lahat. Okay, back to you, President Hilbert.
Yes, thank you, Eileen. Thank you, Becky. Becky, nakamute ka yata.
Ayun, okay na, sir.
Okay. Thank you, Becky, for moderating this webinar. And again, thank you, Sir Bing, for accommodating us to be a speaker. And definitely, thank you all for attending. It won't be a success without you. And keep posted for further announcements because, as I've said in my email, we're striving to do webinars where we can accommodate more than 100 participants. So in the next coming weeks, hopefully we can have 200 or 300 participants. I think there's a lot of fellows in the Philippines who are willing to attend webinars and learn new things. Okay, so I won't keep you long kasi Friday ngayon, baka gigimik pa kayo. Weekend. So that's it. Thank you, and you can visit our Facebook page for further announcements. And ingat kayo lagi, keep safe and keep healthy. But before you go, kung gusto niyo makasama sa picture, just turn on your video and let's take a quick snapshot as a remembrance. And by the way, this webinar is recorded, so we'll be sharing soon a link where you can view this webinar and the previous webinar, and you can just go back and view it, or you can share to your fellow engineers. Okay? So, request ko lang sa ibang BOD if you can also take screenshots. Baka ibang view sa inyo. All right? Hold on. Sorry. So, hindi tayo kasya sa isang screen. So, I have to take 1 or 2 screenshots. Sige, habang nag-prepare ako, pwede kayong mag-supply. Okay. All right. So, okay, smile. 1, 2, 1, 2, 3. Okay, hold on. Another one kasi merong mga nagpa-pop up. Okay, one more. 1, 2, 3. Okay, sorry damihan natin kasi hindi kasya lahat sa isang screen. Okay, next batch. Okay, smile. 1, 2, 3. And last one. 1, 2, 3. Okay, that's it, guys. Thank you so much. Have a good day and have a good evening. Bye.
Bye, everyone.
Bye, everyone.
Meeting, press.
Send ako bagong link.
Okay.
Yep.
Okay.
Send ako bagong link.
Sure.
All right. Bye.